Hey everyone, my name is Mario. I'm the Liquibase Pro product manager, and I want to talk about Liquibase Pro, what it does, who it does it for, and why it's valuable for folks who are engaged in database change management. So let's talk about Liquibase Pro. Liquibase Pro is the paid and fully supported version of the venerable Liquibase OSS project, which has been around for nearly 2 decades and still serves millions of users. The Pro version is built to support and enable modern automated database DevOps. So it's really, think of it as DevOps for the database. So we built Liquibase Pro because we know that when companies move into Liquibase OSS powered database automation, they soon realize that they're also speeding up the introduction of risk, they're speeding up the introduction of compliance challenges, and even additional downtime when they have ungoverned scripting failures. So it's important to put our well-tested structure around your continuous integration capabilities. So you'll notice on this slide, we'll talk about the app development process. This is pretty well known. And so if you're in DevOps generally, you know about source code and validating and building and deploying. What you also need to know is that that is important to do for your databases as well. And no surprise, this is where Liquibase Pro comes in. We support around 60 SQL and NoSQL database platforms, from classics like Postgres and Oracle and SQL Server to more modern entries like Snowflake and Dynamo and MongoDB. I want to talk now for a moment to a particular audience of devs, DBAs, data architects, or DAs, and others who manage and safeguard the most valuable assets, which is your sensitive and critical data. Liquibase Pro really does help you reduce your lead times to change. It helps you safely increase change frequency, and all while adding governance and policy enforcement requirements. These are things that as you get a little more sophisticated in your database DevOps, you'll realize it's not all about speed, but it's also about safety. Okay, so enough conceptual benefits talk for a minute. Let me show you some of the basic nuts and bolts of Liquibase, the key ideas, files, and resources that make Liquibase work, just to show you how easy it is. So first off is the idea of change sets and change logs. And so get used to these words. They are at the heart of Liquibase. Simply, change sets are the atomic changes to your database. Think of things like a SQL script that creates a table or adds a column or changes a varchar from 48 to 96 or whatever it is that you need to do. You collect all of these changes into one item called a change log. It's just a text file. It's stored in source control, like GitHub or GitLab, for example. Very easy, something you're probably very familiar with. This change log is the key file. It enables Liquibase to manage your database changes. And just so you know, change log can call other change logs that help you split up your changes into more manageable chunks. Some people split on features or releases or lines of business. Change logs can be, as you see here, in formatted SQL or XML or YAML or JSON. There are a set of changes, and Liquibase knows which have been deployed, which are yet to be deployed, and doing so, it's able to manage your database changes. So Liquibase OSS and Liquibase Pro work in similar ways around changes and change sets. There are more powers in Liquibase Pro and the kinds of changes that you can do and how targeted you can be with them. And additionally, there's also a feature in your database called the database changelog table, the database changelog history table. The history table is a pro table, and it tracks everything that you've ever done to your database with Liquibase. So this is extremely useful to audit all the changes that you've made, some that you've rolled back, some that you've reapplied. Sometimes perhaps you've dropped all in your database dev environments, for example. And it's super useful for a deeper understanding of all the steps that you've taken in your database change management workflow. This is a pro-only feature, and it is something that once you live with, you will decide you never want to live without it again. All right, so let's look at some quick examples. So the way Liquibase works. There's two examples here, a formatted SQL and an XML. These are both changes that are very simple and straightforward. This is a one change set. It goes into a change log. We're not going to go into kind of technical detail, but you can see how familiar it is. That SQL on the left is very just much straight SQL. The XML on the right, very easy to understand whether you write XML or not. People ask why SQL and XML and JSON and YAML. We like to meet people where they are. So if you only write SQL, great, you're covered. If you want to use YAML or JSON because you're more of the Mongo set, that's great too. XML is handy because it lets us understand a lot of the pieces so we can do a lot more automation with it. But all of these are equally valid, and people use them across the Liquibase Pro. It mix and match as they need. Now that we've talked a bit about what Liquibase is like, let me just show you some of it because it's really pretty straightforward and pretty easy. We'll talk about the update commands and update count and rollback count and the variations. And we'll go look at what the database stores, the database changelog table, as well as a pro aspect of it called the database changelog history table. So just quick, in case you've never seen it, let's do just a Liquibase update. That's a fundamental Liquibase command you'll become very familiar with.
What it does is it looks at a change set, or it looks at a change log that has a bunch of change sets. In this particular case, I am doing just a very simple kind of 10 change sets from a simple change log. Let me just show you what that looks like. I happen to be using formatted SQL here and just running some quick commands. You see they have labels and context and that sort of thing. And what gets stored over on the database side, I'm using a simple H2, just so you can see it. We get these tables that we have from there. Whoops, actually, I want to do that. What I want to look at is the changelog table. So the changelog table is kind of the technical heart of Liquibase in many ways, and there's a lot of other pieces, but this keeps a history of the changes that you have currently deployed. So you can see here, these are very similar to the information that you're seeing here. These are the change sets and when they were run and the order and various other information about them. And you'll notice that if I do, let's say, a rollback count 5, it's going to roll back, not surprisingly, 5 of these. When I come back over here and run this again, you'll see that they're gone. So the database change log table, separate from the database change log history table, if I can get this to go out, shows what is currently deployed. The history table shows you everything that you've done. So you can see that it had some updates, but then it also had some rollbacks. Let's say I then do a couple of more update count 3. I want to update a few more. You'll see it's going to roll those out again, and my history table will have all of those changes as well. You'll see that the difference between the changelog history table and the changelog table, the changelog table is a snapshot of everything that's currently deployed. The changelog history table is a way to track all the things that you've done throughout your history, including your rollbacks and your drop-offs and that sort of thing. And that's just a very quick look at some of those commands and how easy it is to make these changes and have them tracked.
Okay, so that was a pretty good overview. There's a lot more detail we can go into in other videos, but for now, I want to mention some of the pro aspects that really are solutions that will provide a great value to folks who are in the dev, DBA, DA, and management space. And the first one I want to talk about is what we call Liquibase Flows. So what are flows? Flows are a fantastic centralization, standardization capability. Liquibase Flow in itself is an actual command you run, but it runs a thing called the flow file, which is in turn a collection of variables and commands and conditionals in one handy YAML file. And you can think of all of this as a modular building block for your CI/CD pipeline. So they really do let you encapsulate and standardize your best practices, as it says here on the slide. And what that really means, though, is that if you have teams in different lines of business or different app teams within the same line of business or disseminated teams in different countries, and you want to standardize and centralize so they all are running the same commands on your pipeline across all of the nodes in your pipeline, flows are the way to go. You can think of it like a minor orchestration tool within your bigger CI/CD orchestration. And Liquibase Flow and Flow Files provide just a simple way to do all that. They abstract across your CI/CD pipeline because they have variables and conditionals and nuance so that you run the same script everywhere. This is really valuable, and it's a reliable way to increase your speed, efficiency, while governing so that you safely move changes through your CI/CD pipelines quickly. Let's go look at Liquibase Flow. If you are not aware, Liquibase Flow is a command. It's also a set of files called the flow files that run your operations in a consistent, standardized, and centralized way. So let's say you wanted every team and all of your environments to run the same command so that everyone has a very repeatable process. Let's say they happen to be a status and then a checks run to make sure your change log is good, then the actual update, then a checks run against the database to make sure it's good, and then a history so you can see what was actually done. Obviously, you could copy and paste this into everybody's CLI, but that is not standardized, that is not centralized, and that's not a very modern way to do DevOps. So instead, we have the Liquibase Flow file. I'll show it to you real quick, and then I'll actually do a demo because that'll be a little easier, and we'll come back. But you can see that it is running a bunch of commands. In this case, there is a set of actions in a stage. There can be more than one action, more than one stage. We'll talk about that in a minute. Let's just actually see it operate. So Liquibase Flow, it's going to do a lot of things very quickly, which is awesome. And let me go back and explain them. So you can see the commands that we had mentioned in the stage and its actions. We have a status, tells me what needs to be deployed, a checks run, which is to see if all my changelog is compliant. I have a bunch of return code zeros, so that's fine. None of these will stop this job. I do the actual update, and I do a checks run against the database, and then I do a history output. So in this way, I can have a flow file centralized in S3 or GitHub or wherever I have my source control, and everybody on every team runs the same set of commands every time. So this is very handy. And you can see that you have command args and there's global args. There's an end stage. If something crashes out, you can always do some cleanup. Let me show you one more thing. I won't go into a lot of detail, but there's also an advanced set of opportunities that you have. These include things like including other files to set variables with namespaces, global variables, which are good for every stage. So you can see here, I have a stage prep and a stage do work, and I'm using various files. I can also have stage variables, which are good within that stage. There's also the ability to run shell commands. I can do if-thens, I can do conditionals like contains and starts with and that sort of thing, all in the advanced flow file, which is in the docs. And I hope you will find that using flow files is the way to go. Really, frankly, as you get a little more sophisticated and you're running things quickly, you understand that you need to centralize and standardize and make those governable, and flow files are a great way to do that. One of the other things that really governs your pipeline are what we call policy checks. Policy checks are a very important Liquibase Pro capability, and you can think of these as on-demand database checks. They are on demand in the sense that they allow developers as far left as they can go, including on their laptops, to check for compliance with what DBAs and DAs and others in charge of the CI/CD pipeline have said are important. So these checks serve as a gateway between the developer and the pipeline. They also serve to set the same pattern of compliance checks and governance checks on every node of the pipeline, which is very important and very handy, obviously. And so how do they work? The database checks are simply codified conditions from the DBAs and DAs and others in charge of this across a range of themes. These themes are examples like coding standards, which might be to say all of your tables have the same beginning or all foreign keys begin with FK underscore, something like that, as well as security standards where you can and cannot use grants or grant admins, as well as other sets of permissions, or things like regex and SQL patterns. Whatever fits your requirements to make your database administrators and data architects and others happy that the code that is going to move into the database is compliant to their conditions. So you can see here we have database checks that work all the way to the left. And what's nice is that they can also work automatically. So the developers run these checks and either it goes forward or it doesn't go forward. And this works in automation as well. You can work this even further left so that every PR or every merge has the same thing happen to it. The same set of standards, the same set of compliance rules, the same set of conditions are met before it moves on. And this frees up DBAs and DAs and others to work on things that are a little more high value than just making sure all the code is compliant to the conditions that have been set. And so they know that every database change is going to be exactly what it needs to be. And this is a very big time saver. So one of the other high-level aspects, maybe more advanced aspects of this, let me just tell you real quick, is about how rules are enforced. You can make sure that the changes to your database, the scripts that are going to make these changes to your database are compliant before you make the change, but you can also make sure that the changes that happen are compliant to what you intended. This is important to understand because sometimes changes are actually a fine change. They don't violate any of the rules, but once they get into the database, some things kind of happen that you did not intend or that you did not desire. So you can make sure that both sides of it, before change and after the change, are compliant. And it's an important thing to note how this really amplifies the reach of the DBAs across all of the domains that they have to look over. There's some ways to make this even simpler, which are using things like policy checks packages. So policy checks packages are a way to run different policy check settings across different pipelines with different conditions, but using the same checks as needed across all of those conditions. So when I mentioned before that there are themes of checks, we often have people write a check settings file that's just, say, coding standards, and another check settings file that is just security standards or how regex works, that sort of thing. You may want to split these up on, say, a UK team has a different set of standards than a US team, or one app line or app dev line has a different set of standards than another, and these get broken into different packages. So it makes it very easy using policy checks packages to assign the right set of packages or the right sets of checks to the right teams. And because it's standardized and centralized, it makes it very confident, you have high confidence that every team is running what they need to be running. This also allows for a separation of duties and it adds extra security because not everybody can make those changes. And it's very convenient because one team that's allowed to make those changes does it in one spot, and everybody across the entire organization, which can be global, is running all of the same checks and making sure that all of their agreements are being met. So let's just jump into a actual demo of what policy checks look like. So the first thing I'm going to do is just do a Liquibase checks show so we can see all the various checks. These checks are the ones that ship in the box. There's about 30 or 40, I'm not even sure at this point. As you can see, there's a table here that shows some are disabled and some are enabled. You can see some are not customizable and some are customizable. There's descriptions about what each check does. So these policy checks are in groups, as I've talked about, or themes. So these you can sort of see are coding standards. You get some checks around grants and admins, reserved keywords, other ones around various permissions and that sort of thing. So let's just jump into a checks run so you can actually see what happens. And then we'll come back and we'll talk about what actually it is like to customize a check and separate them and theme them up and that sort of thing. First, let me type this correctly. And what we'll see here pop up here in a moment is a checks run report. These are optional. They're enabled by default. You can, of course, turn them off. Globally, you can turn them on for specific commands like checks run or update or rollback, and that is up to you. So this is a friendly, portable, shareable HTML report. It has a summary view of what happened. I ran my enable checks. There were 5 checks that detected issues. It's important to think of checks as triggering, not necessarily as failing, because sometimes you want a check to indicate that some condition has been met, but that's for auditing purposes. It's not because something is wrong. It's actually because something is correct. So in this case, you can see we have details by change set, details by the database, or details by the check itself. In this particular case, this ID, this change set ID failed 2 checks. It does not have a context and does not have a rollback. This one has no label. This one has no context. So those are the ones that are run here. So let me actually just jump into a couple of things that will help make this a little clearer. Oops. If you don't know, you can do check status enabled, so you can filter down. You don't have to see that in giant table. So I'm going to see, here's the checks that I have enabled right now. These are all sort of coding standards checks. I happen to have these enabled. And this helps me sort through the things that I want to look at and not look at everything. I'm actually going to make a new check. Oh, you know what? Before that, I'm going to show you the console output. So there's the HTML portable document that we created. But we also have a console version for those who want to do it this way. It also comes into the structured logs. So you can see it's a lot of the same information. This check name, change that label check, you must have a label assigned. Turns out in this change log, this change set does not have that. But let's go back up here. We're going to do a user-defined context check. So what this check says is this check confirms that a specific context matches a pattern. So let's go look at what I have here. You'll see that I have contexts on not everything, but on some of them. Some of them have Jira and some of them don't. I'm going to write this check to say I want all of my contexts to have Jira in them. So let me clear this out. So we're going to do a Liquibase checks customize. And the check we want to customize is called the user-defined context check. So this is going to walk me through a couple of steps. It's just going to ask me a few questions. So I have to give it a short name. I'm going to say context must have Jira. Oops. And we'll spell that correctly. And I'm going to make this critical, so I'll give it a 3. So these severity codes, also known as return codes, help you decide what you want to do with this information. If you leave it at a 0, then you'll just get this information in your log. And depending on how you have your CI/CD tools set up, you can return different exit codes to condition the job to stop or not stop, depending on how you have your tool set up. I'm going to use a contains, and I'm going to say Jira. And just like that, I have a new check called context must have Jira. So let's run just that check because I don't want to run everything right now. So we'll do check name again equal to context must have Jira. And we will get a report again here in a moment, and we will also get the other ones. We'll see 7 chain sets were flagged. So all of these chain sets do not have Jira in the name. So we can view these by the check itself and see them here, or we can view them by the chain set. So this is very handy for different use cases. And if we go over here to this, we'll see that a lot of these, in fact, do not have Jira in their names. Hey everyone, I'm going to do a quick demo about Liquibase policy checks that are custom. That is, that they are customized with Python. So let me just do a quick checks show. Oops. And if you did not know, it's also handy that you can do wildcards. So I'm just going to list the Python checks. I've conveniently named them all beginning with Python so that it's easier to see just a few things rather than everything all at once. So these are all enabled, and these are the only ones that are enabled, which you can also do with a checks stat. Whoops, checks stat. Oh my gosh, check status equal enabled. And this is a way to shortcut the list of that, quite possibly long items that will show up when you do an unfiltered check show. So let's do a checks run. And this is just going to run these 3 Python checks. One of them is database scope, so it's not actually going to run. And this might take a moment because it has to go launch up Python and run your script, which we'll talk about here in a moment. But it doesn't take that much longer. We'll see a report pop up here any moment. Here we go. And so you can see here that I have a couple of checks that were run and a couple of chain sets that were found. In particular, so this Python no all caps tables names and Python delete needs aware. So you can see this, the table company should not be capitalized in this create table company chain set. And in this chain set called Jira 300, there's a chain set found with a delete, but without a where clause. And just for interest, let's go over here and look at this. So I have a couple of very simple chain sets just to trigger those things right there. All right, so we do this through Python, which is what makes these custom Python checks. So this isn't a Python tutorial, but I'll just show you some quick bits about how it works. So if you know Python at all, we've got some setups. In this particular case, I have some debugging statements, which are turned off. We have some built-in utility helpers. There are several of these. They're in the API docs that help you do things like get change sets and get the changes and generate SQL that you can go through. This particular check basically is creating a tokenized list and looking through for certain conditions. In this case, trying to find a table, and is the name of that table uppercase? If so, it fires with a message using some property or some variable substitution so we can get a message that says table company name. All right, so let me go back to over here and show these Python ones. And I'm going to delete a check and recreate it just to show you how quick it is. So this one, Python delete needs aware. So I'm going to base checks delete equal that. And we're going to delete this check. Goodbye check. And we will show them again. And this should now just be 2. And then we will jump into creating a check. Okay, I've cleared my screen and I'm going to use the shortcut I showed earlier to look for the check I want to customize. I happen to know it's called custom check template. It is the base template from which all Python checks are built. So we're going to customize that, and we will use that with base checks. Oops. Custom check template. It's going to ask me a series of questions. I'm going to do one other thing, which is I think it is a good habit to name your check after your Python script. It makes it very easy to catch things later on. So give me a short name for your check. I'm going to call it Python delete needs aware. And I'm going to put this one at a 3. I'm going to set this to say this check triggers when a delete is found without a where. All right. And this is going to be a changelog check, so I don't need to do anything. I will say a delete. I'm going to capitalize this. We'll just say delete was found out a where was. And then we'll set this as a Python script. The path is checks. This is what I happen to know, .py. This is where I keep all of my custom checks. We are not passing any arguments in this check. You can. This is a way to make your checks a little more templatable so that others can use your check and customize it along the way. And this does not require a snapshot. And so there we have now, if I go back to here and do a Python star, we will see that we now have a check again. That's called Python delete needs aware. So let's just run this one check. And then we will customize it a bit further after that. So let's do this. We should open up a report in a moment. Okay, the report has opened up, and we can see that it did find, in fact, this change set ID, 0300, that does not have a where clause. So let's go look at that script real quick. And, as I said before, this isn't really a Python tutorial, but there are a couple of things in here that are worth showing. So this, is this one. So you can see in here, we do some regular imports of things. We set up the logger, we get the status, we get the changes. Pretty simply, we go through and we build a list. And if we find a delete and we don't find from an aware, then we trigger the check. So I want to make this check a little bit more informational in its output. So the delete was found without a clause. So I've already set this up. I'm going to use another Liquibase utility called Liquibase change sets. And I'm going to set up a change set ID using that Liquibase utilities. And then I'm going to adjust my status message to say, use change set ID and change it with change set ID. And the very clever among you will have noticed that I don't actually use the word change set ID in my message thus far. I can go in and customize it through the CLI, but in case you didn't know, you can also customize things through the YAML file. So the check settings config is a YAML file, and your new checks are conveniently at the bottom. So what I'm going to do is I'm going to add in here a delete in change set ID was found without a where clause. And so this message is going to be, this message, status message, and it is going to swap out this placeholder with this value, which was set up here. So let's just see what happens. We'll do the same check again, and we'll wait for the report. All right, we have the report is opened automatically because it's how I have my settings, and we just see a delete in 0300 is found without a where clause. So I hope you can see that creating a Python check is mostly about the Python. In terms of Liquibase itself, you really are doing the same sort of walkthrough that you do with any customization, except you're adding a checks path, and that's pretty much it. Next, I want to talk to you about policy checks packages, which are really just a convenient way to aggregate your different check settings files. As we've talked about, you can have different themes and different setups. This is just a nice way to do that.
Okay, so let's go look at a checks package file and understand why we would want to split checks control file or check settings files into different files. So you saw me just truncate a file so that it's more handy, more convenient, more related to one particular theme. So let's say I did that across different concepts. Maybe I have a bunch of checks that are different based on nodes in a pipeline, or maybe I have them based on different app teams, or maybe I have them based on different platforms, special checks that are just for Oracle, just for Postgres, or just for et cetera. So what I can do is I can make a master file that points to these various packages. This means that I can store all of my checks in one spot on an S3 or Azure or GitHub, et cetera, in my source control, and everybody everywhere in my entire org can use all of the same checks, and only one person or one team makes the changes, and they are automatically disseminated. So you can see here, let's say I were to run this check settings file, or checks package file, it's called checks packages. If I just run this command, it'll run everything in here. But let's say I've got app team 1 and they need just the Oracle and Postgres checks. Then I just tag on checks packages, and I can tell you, and it will run only the one. So app team 1 will run these files, which has been made by different teams. Let's say a security team and an overall DBA, DA team, maybe something specific to a particular app team, as well as some checks that are particular to some platforms. And in this way, standardization and centralization become your very best friend, and it becomes very quick and efficient to make sure everybody's running the same checks, and only a few folks who can make those changes are allowed to make those changes, and everybody is on the same page.
Okay, let's talk about one more very interesting aspect of policy checks. This one's a little advanced, but it's frankly still quite simple and very useful.
So often you will have multiple checks that you want to run against every change set. And using the example from before, this might be must have a context, must have a label, must have a comment, let's say. So that's 3 checks, and let's say you had 50 change sets. That's 150 items in your console or your log. And instead, let's reduce that to 1 output for that whole check. So we have a change check template here, which I will now customize. I'll show you how quick and easy it is. Let's customize it. We will call it must have context, comment, label. We'll call it whatever we want. We're going to make it pretty severe. We'll call it a 3. So here I put in a little logic. So it must have the change set label, check, and it must have the change set comment, check. And it must have the change set context, check. That's my logic addition, and I'll take the default message which says it must have all of those things. And now you'll see that I have this check. So I'm just going to run that once, just so you can see what it's like. Oops. And instead of getting multiple outputs for all of them, well, turns out all of mine do have that. So great, I passed. So this is how you chain checks together. You can even change the checks. It's very good for reducing, I wouldn't call it noise, I would call it output in your console and your log. It makes it a lot easier for people to stay on top of compliance and policies.
Another Liquibase Pro value is how it integrates with credentials vaults, also called secrets vaults. These are tools such as AWS Secrets Manager and HashiCorp Vault. So rather than passing direct information like URLs or passwords, really any Liquibase property, you store the vault information with Liquibase and we grab it dynamically. So Liquibase retrieves those as encoded secrets and no one knows them. They're not in source control. They're not available to prying eyes or logs or dashboard outputs. Another related tool, which does it very handy, are remote resources. So you've heard me talk about keeping things in a centralized way for teams that are disseminated across the world or just even across a big organization. So Liquibase integrates completely with AWS S3. So you can store your resource files there, like change logs and flow files and check settings files and log data customization files, et cetera, et cetera. These are centralized in one secure location using AWS S3 so that you can pull them, everyone in all of your teams can pull them directly and use the same files everywhere. As I've mentioned, when folks implement Liquibase Pro, they push more changes through their DevOps pipeline, which is great. But soon it becomes clear that they need additional capabilities to understand what is actually being pushed through their pipeline. What are all the actions and the outcomes of these operations? This is often called observability, and Liquibase approaches this in 2 ways. So I'll talk about structured logging, and I'll talk about snapshot reports. So structured logging is the industry standard JSON logs that can be delivered to the observability platforms of your choice, things like Datadog and Splunk and AWS CloudWatch and many, many more. So structured logs capture the commands and the checks and the outcomes and other key details from your automated pipeline steps. So out of the box, you get DORA metrics, but you can customize this and get the metrics and reports and dashboards that you need for your business needs. You can set up custom objects into your logs and you can suppress certain objects. You can set up triggers for alerts and notifications to improve your security stance or kick off other conditional operations. Structured logging also simplifies root cause analysis and auditing, which helps you find and squash bugs. As you can see, here is a dashboard in Elastic. This is a screenshot of a real dashboard. By feeding our structured logs, ingesting them into the business intelligence tool of your choice, you can get reports that tell you things like frequency of deployments and success failures, when jobs are running longer than you expect, who's doing the changes, detecting drift, and lots more. The other dimension of observability are reports, which you can think of as snapshots in time to help you monitor change operations. These reports serve a whole range of people, devs, DBAs, DAs, the managers. All of the reports provide fine-grained and summary data. So depending on your role, you can find the information that you need. There are 4 distinct kinds of reports right now that Liquibase offers. These are the drift report, the checks report, update reports, and rollback reports. Just here real quick, I'm going to show you a drift analysis. So a drift report is when you run diff between 2 different targets. We tell you what the differences are, what's on one database, what's on the other, what's on both, but different. We provide it to you in a very friendly format. This is very, very handy. These reports are enabled and generated at the moment that you do your diff, so they are snapshots in time. But as you collect these, you can build patterns across time, and you can understand which databases are having drift or which teams are experiencing drift. Same with the checks reports or the update reports. They tell you things that have failed, things that have succeeded. And because there's meta information, you can really build a pattern that helps you educate all of your users, collaborate with all of your teams to find those differences and remediate them in very efficient and effective ways.
Let's talk a bit about reports and observability. So observability is a broad category of things that we say from Liquibase. It includes things like logs and it says and reports. And there's a very handy URL. Just go to docs.liquibase.com/observability, and you'll be able to see different kinds of reports and the different kinds of structured logging. I won't run through docs with you here, but I'll just show you how you do it. It's really pretty simple. Liquibase update command, for example, just right off the bat. That's a pretty standard command you're probably familiar with. Did you know that you can add report enabled? And you can do this through the CLI, or you can do it through a property environment variable, that sort of thing. You can see that now that I've turned this on, a report was created. So let's just go take a look at that report. So, and I'll just show you a bunch of reports here. So here's an update report. Everything was successful. So this report doesn't have a lot of problems to show you, but it does nicely indicate all of the basic metadata. It's got a nice summary table. So this is very handy for devs on the far left. If something goes wrong, you can see it immediately, or DBAs and DAs a little bit further in the pipeline, for devs when they're trying things out, and DBAs and DAs when they're working on this sort of thing in the pipeline itself. Let me go to some other examples. So checks runs reports. So if you've seen some of the checks runs videos, this is a report that's as simple as that one, where there's just sort of 3 things that were caught. You can view it by the change set, or you can view it by the check itself to see which one was caught. We'll give you an example where more things were caught. No, that's not that one. Here's our rollback one update report. As you can see, they're all very similar, and they're all enabled by just literally doing a global reports enabled, or a command on each command that you want. If you don't want reports for everything that you do, on the Liquibase rollback one update -- report enabled, Liquibase diff -- report enabled. And that will give you a drift example. Let me actually show you a couple here. So what's nice about the drift reports, so these are from a target and a source, and it tells you, what was different. It tells you, which ones were the same, but with differences, missing one side or the other, and it gives you the straight out SQL differences. So this is very handy, again, at the dev level, DA, DBA, etc. And then the overall report of things happening or not happening is used for managers too. So these are some of the reports. And again, it's as straightforward as adding -- report enabled or doing it at the command line. The other thing for you to remember is this very simple URL, Liquibase /observability.
So Liquibase Pro and Liquibase OSS do a lot of the same things. The Liquibase Pro does offer several distinct advantages, especially in the form of pro-only commands. There are many, but 2 very handy ones I'll point out right now. One set performs targeted rollbacks, and one set performs targeted updates. So what is a targeted rollback? Let's say you're an OSS user and you need to roll back because you've noticed an error, and say it was 10 change sets ago or 50 change sets ago. With OSS, you have to roll back all of your good change sets in order to get to your problematic change set. Targeted rollback lets you avoid that and lets you roll back only the change set that you know to be bad. And then when you're ready to fix forward, you can use targeted updates, which is the update one change set command, to just deploy that one change set, even if there's a lot of other change sets pending deployment. Normally with OSS, you would have to change your change log so you have only one item in it to be deployed. So the pro commands offer a real benefit in efficiency, whether you roll forward or do targeted rollbacks. There are times when you need the power to pick exactly the change that you need, and Liquibase Pro lets you do that.
This quick demo, I'm going to talk about 2 pro commands that really help when mistakes happen, because they do happen. These are going to be the targeted rollback and the targeted update. So in OSS, when you have to roll back a change set, you have to roll back all of the change sets that came after the one that is the problematic change set. And then you have to fix it and then redeploy. So with pro commands, you can actually target that one and eliminate it and then put it back. So I've just done a simple update here, and I'm going to do a history command, which, if you don't know, the history command is very handy for getting the information that you need to run a rollback one change set. And that information is this change log path, change set author, and change set ID. So you don't have to watch me type. I have already written this out. And so you can see I'm going to roll back It's an MMC changelog, and the create foods. This is this change set. Let's just pretend this is a problematic change set. And then what you'll see is it says, oh, you actually have to use the force flag. So because this is a potent and powerful and potentially destructive change to your system, you do have to take the extra step of adding force. So you can see I've now rolled back one change set, and it's totally gone from my database. So if I want to do that in reverse, let's say I go back to my changelog and fix it, then I have an update one change set, which is a very similar command. It just works in the reverse. And that's some of the power of the Pro commands in order to be more effective, more efficient, more targeted, more precise.
Well, thanks for joining me today. I hope you learned a lot about Liquibase Pro. It's true, Liquibase OSS will get you started on your journey, but Liquibase Pro will be the one that takes you where you need to go when you need governance and compliance and security to understand how a CI/CD pipeline works at production scale. So you can contact us at theliquibase.com/contact. You can scan this QR code, visit the docs to learn more, and get in touch. And we'll be happy to set you up with a professional to help you get started on your journey.